All right, so up to this point, we have been differentiating explicit functions. So what do I mean by an explicit function? I mean where y is equal to something, or one variable is equal to, is set apart, where, let me say that again. Basically, when one variable type of variable is on one side and another is on the other. So here our y's are separated from the x's, right? So the y's are on the left side and the x's are on the right. What, the function y is stated explicitly in terms of x. I'll get my words right eventually, right? That's why it's called an explicit function. Today we're going to learn how to differentiate implicit functions, right? So when the x and the y's are on the same side, right? No variable is being defined in terms of another variable. So is it possible to find the derivative or the slope of a function in this point? In this form? Yeah, sure it is, right? We could put that on Desmos and we'd be able to find the slopes at each point. So sometimes, like in this case, it would be really easy to just rearrange and solve the equation for y, and then you can differentiate it in the way you know how to. But most of the times you'll be given a function where it will be really hard to do that, so, or more work. So then you want to just be able to use implicit differentiation to solve for that, okay? So really implicit differentiation is just an application of the chain rule, which we learned last time. And so I'm going to go over that. So for example, let's do this easy one here. 4x squared minus y minus 1 equals 0. So if I had to find the derivative of that, well, I can find the derivative of 4x squared, right? That's 8x. Could I find the derivative of minus y? Eek, right? Well, I'm going to find the derivative of y in terms of x. And how do I find that? Derivative of y with respect to x. That's what the derivative of y is, right? And that would be the same if we had set up this equation where it was y equals 1 minus 4x squared. We would have dy over dx equals all the other things, right? Because that's what we're finding, the derivative of y with respect to x. Okay. What's the derivative of the third part? Minus 1. Well, that's 0. What's the derivative of the right side? 0. Well, that's 0. So what do we have here? We have 8x minus dy over dx equals 0, which means 8x equals dy over dx, right? Which would have been the same thing if we had rearranged this equation like that, right? We would have gotten the same thing. You can also do it without rearranging. So when you're having to implicitly differentiate, you want to differentiate both sides of the equation, right? Which we've actually been doing, but you guys haven't really been thinking about it because one side is always dy dx or y prime with respect to x. Then you collect your dy dx on one side of the equation to solve for that. Okay, so let's try this. So here's the first example. X squared plus y squared equals 1. So it's asking me to find the derivative. Okay, let's just rewrite the equation. And we're going to derive this implicitly. So what is the derivative of x squared? Well, that's 2x. What's the derivative of y squared? Well, we have to use the chain rule here. Why? Because y is a function that is in terms of x. It's the inner function is y. The outer function is the squared function. So to find the derivative of this, what's the derivative of the outer function, the squared function? Well, that's just 2y, right? But since we're using the chain rule, we also have to derive the inner function. So the inner function is just y. What's the derivative of y? Well, that's dy dx. Equals. What's the derivative of 1? 0. So now if I rewrite this, I need to solve for dy dx. So let's rearrange this equation. 2y dy dx equals minus 2x. So dy over dx equals minus 2x over 2y, which then I know those can cancel out, so it just equals minus x over y. So dy over dx equals negative x over y. Okay, got that. Now, so let's think about that. That's saying to find the slope of the tangent line at any point, you need to take the negative of the x coordinate and divide it by the y. All right, so now let's do b. B says to find the slope of the tangent line when x equals 1 over root 2 and y equals 1 over root 2. Okay, to find the slope of the tangent line, I just need to solve for dy over dx, which we've figured out equals negative x over y. So now if I plug those in, negative 1 over root 2 over 1 over root 2, that comes out to just be negative 1. So the slope of the tangent line at this point is negative 1. All right, C, find any points where the tangent line is vertical. So for dy over dx to have a vertical tangent, what are we looking for? Well, the slope of a vertical line is undefined. So it must be undefined. So how are we going to find a slope when it's undefined? That means the denominator has to be 0, right? So that means if dy over dx equals negative x over y, that this thing right here has to be 0. That's how we're going to get it to be undefined. So we know that the y coordinate has to be 0. Right? So that is the solution right there. This thing will be undefined when y equals 0. And we could think about it. Hopefully you guys remembered what this function is, right? X squared plus y squared. That's just a circle with a radius of 1. Right? Well, it's not a function. I keep using the word function, but it's not a function, right? Because it doesn't pass the vertical line test. So my error there. So the radius is 1. So if I think about it, when is y equals 0? Y equals 0 at this point and this point. Why did I do that? That's x equals 0, Miss Harrington. Y equals 0 at this point and this point. So these 2 points, right? And so when the y equals 0, you can see that the tangent line would be a vertical line, so therefore the slope would be undefined at these 2 points. So it's when y equals 0, but it's also when, you could say it's when x equals 1 or x equals minus 1. Okay. Example 2. Find y prime where x cubed plus sine y equals 3y squared. Okay, so we're just going to differentiate each term. So, with respect to x, what's the derivative of x cubed? Well, that's 3x squared. Plus, what's the derivative of sine y? Well, here this is a composite function. The outer function is sine and the inner function is y. So what's the derivative of the outer function? So I'm going to mark this. This I need to use chain rule. The derivative of the outer function, sine, is cosine. The y is still in there. Times, what's the derivative of the inner function, y? Well, that's dy dx. Plus, or no, equals, not plus, equals 3y squared. Okay, so here, this is also chain rule, right? My outer function is actually this 3 something squared, or really I can just take the 3 out because it's a constant, so it's something squared, right? So what's the derivative of this outer function? Well, that's going to be, take the 2 down, that's 6y, and then 2 minus 1 is 1, times, well, the inner function here is y, so what's the derivative of the inner function? dy dx. Okay, so now let's deal with this. This comes out to be 3x squared. We want to collect our dy dx's on the same side. So what I'm going to do is this, 6y times dy dx, and I'm going to move that dy dx term over here. Right? So I'm collecting them on the same side. I moved it over. So now, if I'm solving for dy dx, I want to factor it out. So what's left inside here? 6y minus cosine y. So then my last step would be to say 3x squared over 6y minus cosine y equals dy dx. So that is the derivative of that function. I think I made a mistake here, right? No, minus. Yeah, minus. In my original, no, that's right. Yeah, I thought I had a negative in the wrong place. Just double checking. Okay, last example. Consider the curve y cubed plus 3x squared y minus 6x squared plus y equals 2. So they're telling us that show that the derivative of y with respect to x equals that. Okay, so we're just proving it. So let's find the derivative of this thing, term by term. So y cubed, well, the derivative of that is going to be 3y squared times dy dx. Right? The derivative of the outer times the inner. All right, plus 3x squared y. Uh-oh. That is going to require that I use the chain rule, or sorry, the product rule, because it's a product. Right? I have 3x squared as one term being multiplied by y. So I can call this product rule. I'm going to do this work on the side. I'm going to say u equals 3x squared and v equals y. So du equals, or let's say u prime equals 6x and v prime equals dy dx. Right? So now when I come over here, I can actually write it out. What's the product rule? It's u times v prime, so 3x squared times dy dx, plus v times u prime, or 6xy. I'm going to write it like that. Okay, that's all for the second term. Let's go to the third term. What's the derivative of minus 6x squared? Well, it's minus 12x. All right, what's the derivative of plus y? Well, that's just plus dy dx. Equals, what's the derivative of 2? 0. Okay, now we just need to get dy dx on one side of the equation. So let's figure that out. So we have here 3y squared plus 3x squared plus 1. All of this times dy dx, right? Do you see what I did here? I just collected all my terms that have a dy dx. Positive 3y squared, positive 3x squared, and then positive dy dx, so that's that plus 1. And then I factored out the dy dx. Because then what I'm going to do is move everything to the other side. So if I take let me get a different color. If I'm going to move the other things to the other side, I'm going to move this one to the right side, move this one to the right side. So if I move plus 6xy to the right side, that becomes minus 6xy. And if I move minus 12x to the other side, that becomes plus 12x. Okay, so now when I solve for dy dx, I have negative 6xy plus 12x all over this right here. 3y squared plus 3x squared plus 1. Does it match? Yes, we proved it. Great. So this was A. Part B says, write the equation of each horizontal tangent line to the curve. Okay, a horizontal tangent line means that the derivative has to equal 0. So let's set this thing equal to 0. Okay, well, so that gets multiplied out. So then we have 0 equals, right, if we do cross multiplication, equals negative 6xy plus 12x. The numerator has to be equal to 0. So I can do 0 equals, we can actually factor out, let's factor out 6x. Because then what would you have in here? You'd have minus y plus 2. Right? Okay, so 6x can be 0, or negative y plus 2 can be 0. So x can be 0, or y can be 2 when I solve for those. Right? So let's check these. So when x is 0, let's come off to this side and do it. I'll do it in pencil. When x is 0, let's plug it back to the original equation. What would y be? Up here. So if x is 0, we'd have y cubed plus this second term will go to 0. There's an x there. This third term will go to 0. There's an x there. Plus y equals 2. So we have y cubed plus y minus 2 equals 0. So what would y have to be to make that work? This would have to come out to 2. Could we get this to be 2? Because so that when you take away 2, you get 0. Yeah, y would have to be 1. Right? So for this to be a point, a solution, you would have the point 0, 1. So that works out. That's one solution. Now let's check when y equals 2. I always want to go back and check. So I'd have 2 cubed plus 3 times 2 would be 6. So 6x squared minus 6x squared plus 2 equals 0. All right, so 2 cubed comes out to be 8 plus 6x squared minus 6x squared. That goes away. So 8 plus 2 equals 0. Well, that is not a true statement. So that is not a solution. So there's only one solution for when this function has a horizontal tangent line, and it's at the point 0, 1. All right, that's the end of implicit differentiation. See you next time.